So this is my video on operations of functions. So in the last section, we learned that if you have a function as a graph, say, right, we can get different other functions by shifting and shifting to the left and then stretching and so new functions from old, right? That's what we really did. It's from old, right? Okay, so this was like the old function. We're going to do another way of finding new functions from old. Old functions, and that is using operations on functions. So let's try to do an example. So if you have, so if you have x squared plus x plus 2, and then say gx is equal to say x squared. So let's do an example. So find a f of x plus f plus g of x, right? B f minus g of x, C f g, and D f divided by g when g is not equal to 0. So this is pretty easy. So these are new functions. Remember, the function f is given as an equation here. Function g is also given as an equation here. So let's try to find the function, the new function f plus g. So if you want to define that function f plus g, it's defined so that if you take any input, the output will be, the input is x, then the output will be the output from the function f plus the output from the function g. This is the definition. So to do that is very easy because we know that the output from the function f is x plus 2 and the output from the function g is x squared. Let me just add something to this just to make things a little interesting. So x squared plus say 2x, right? Let me call my gx x squared plus 2x, okay? Then gx will be x squared plus 2x. So then I need to combine the like terms, right? So added the fx and gx, and then I have my final answer as x squared, and then x squared plus 2x is 3x plus 2. So that is your new function f plus g of x, okay? So similarly, you can find f minus g of x, which is defined so that the output of this new function for x will be the output from f minus the output from g. Then the output from x is x plus 2 minus the output from g is x squared plus 2x. So you will get x squared plus 2 minus x squared minus 2x, right? So you get 2 minus x squared minus x. That is your f minus g of x, okay? Okay, so that is your f minus g. So now let's go and do fg. That's a new function. So this is a, b, c. So the new function fg is defined so that if you take any input, the output is very easy to calculate. It's just the product. So this is my second part of the video on 2.6 where we do compositions of functions. I'm sorry for the abrupt ending there, okay, in the first part, but we were actually trying to find the product fgx, right, of two functions f and g, right? Okay, and that's very easy. It's the output of f times the output of g. Okay, and then what is going to happen is f of g is so that you know uh, the output of f we know is x plus 2 will be times the output of g is x squared plus 2x. So now what we do is we should actually try to FOIL this, right? And then if you try this, you get x cubed plus 2x squared plus 2x squared again, right? Plus 4x, right? So now you can combine the 2x squared and then you get 4x squared, x cubed plus 4x. All right, now let's take a look at the quotient, right? Okay, so the quotient is actually, so let's start that from a new page, right? Okay, so the quotient, so you want to do D now. So that for that you need to find f of g, f divided by g. Okay, and that is pretty easy to define. It's simply the output of f divided by the output of g. Okay, correct. Okay, so that's very easy because output of f we know is x plus 2 and output of x and g is x squared plus 2x. Gotta make sure that this is not equal to 0. That is very important here because if the denominator is 0, then we are in trouble. So we have x plus 2 divided by, if you take out the x, you get another x plus 2. And this will cancel off and you get 1 over x. So you got to make sure that x is not equal to 0 because only then we'll have the quotient valid. Okay. So a, b, c, d, e, and all were pretty easy. So you are given two functions. We want to find the sum, the difference. You just take the sum of the outputs. Difference, you take the difference of the outputs. Product, you take the product of the outputs, and the quotient, you take the quotient of the outputs, keeping in mind that the denominator is not equal to 0. But now we are going to do a different type of operation, right? So that's called composition of functions. So to give an example as to why we do this, right? Okay, so for example, suppose we have one function which says input, say the year, and and then suppose the output is the population of Madison. So for every year, it will give the population of Madison. Suppose you have another function, say G, where you have the population, where the input is the population, and the output is the pollution. So that's G. So a family which is coming to Madison, is planning to move into Madison, will be interested. Suppose the family is not interested in the population by the year, nor is it interested in the pollution through the population, but really it wants to find out the pollution in 2025, say. If you want to get, then you need to connect the year and the pollution. So really, you need to connect these two. In order to connect these two, you need to actually take this output of the second function and throw it inside the input of the second function and throw it inside the output of the first function. So the input of the second function has to go inside the output of the first function. Okay, so this is really the idea of, this is not a sum nor a difference nor a product or a quotient. We are trying to get these functions one inside the other, and that is called the composition of functions. So let's define it. So we define f circle g as f of gx. In other words, the output of g becomes input of x. And on the other hand, we put g circle f of x as g of f of x, where we have the output of f becomes input of g. So now let's do an example. Okay, so let's find f circle g and g circle f for the same two functions when f of x is equal to x plus 2 and g of x is equal to x squared plus 2x. All right, so first of all, let's find f circle g of x. So watch what I'm doing. Okay, so in order to do that, what you do is, that is the same as f of gx, right? So what happens is you are going to change the input into gx. Input of what? Input of f. So you start with f. So what is f? Now f of x is equal to x plus 2. What you do is wherever you see x, you replace it by g. So f of g, f of x equal to, so you see x here, you replace that by g. And what is g? We know that g is equal to x squared plus 2. So what you do is you replace the x by x squared plus 2x, only the x. What about this 2? That is still outside, that is 2. So once again you start, because f is outside, you start with f and you write down f, and then you replace the x of that f by the new function, the second function, which is g. So the x get replaced by x squared plus 2x plus 2. So you have f of gx is equal to x squared plus 2x plus 2. And that is your f circle g of x. Okay. So now let's find g circle f of f. So by definition, then you start with g and you replace the input by f of x. So now you go to g. Okay, so what is g now? G is equal to x squared plus 2x, right? What you're going to do is you're going to replace wherever you see x, you're going to replace it by f now. So first we start here. So we're going to replace the x by f. So f is x plus 2. So we have x plus 2 squared plus 2 times 2 is still there. So remember, you only replace x. The 2 in the exponent is still there. The 2 here is also still there. And you replace x once again by x plus 2. So you have, if you expand this, you get x squared plus 4x plus 4 plus, when you distribute the 2, you get 2x plus 4. So you get what? X squared plus 4x plus 2x is 6x plus 8. So x squared plus 6x plus 8, and that is your g circle f of x. Right, and that's it. So sometimes they ask you things like, okay, find f circle g of 3. Well, then there are two ways of doing this, right? Okay, and one way is you find f circle g of x and then plug in x equals 3. So you can do that because you already found that f circle g is x squared plus 2x plus 3. So you take the x squared plus 2x plus 2, right? And then you plug in x equals 3. Then you get 3 squared plus 2 times 3 plus 2, which is 9 plus 6, which is 15 plus 2, which is 17. So that's the answer for that. Thank you for watching.